All right, the first two problems is just like the first assignment in chapter 9.5 after we had the last test. That you don't have to solve. It doesn't say anything to solve, and I forgot to cross this out. You're not going to have to write it as a decimal, so you can cross that out.
You crossed it on our thing.
Oh, I did? Oh, okay. So find the sine, cosine, and tangent of the acute angle A. So you want to find the sine of A, cosine of A, tangent of A. You don't need to solve anything, you just need to write what the sine of A is. So here's A, so what's the sine of A? Opposite over hypotenuse, 5/13. That's all you got to do, no solving.
We should
Vice
have all the
versa.
questions like that.
Well, almost all, just the first two.
No way.
And everything after that isn't.
You got it.
Cosine of A is adjacent over hypotenuse. And then the tangent is opposite over adjacent. So remember, you do need to know the trig functions. SOHCAHTOA is the acronym that helps you remember. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So for this one, again, just find the sine of A, cosine of A, and tangent of A. Sine of A is opposite over hypotenuse, 7/25. Cosine of A is adjacent over hypotenuse, 24/5 or 25ths. Tangent is opposite over adjacent, 7/24. Again, like Jojo said, the easiest ones on the test, but every year there's some people that try to actually solve something even though it doesn't say to solve. So remember that. Sometimes they're so easy, they're hard. Now we get into the ones where you got to solve. So remember, when you solve a right triangle, that means find all missing pieces. So you're going to have three answers for each of these. You're either going to have to find two sides at an angle or at one side and two angles. If it's a triangle like this, the angle is easy to find because they got to add up to 180. So all you do is subtract these two off of 180, but the quicker way is, since this is 90, these two got to add up to 90. So just take 90 minus 50 and it'd be 40 degrees. Then to find the side, you can either label it down here, or if you want, you can put it right on the drawing too. Doesn't matter. To find a side, it doesn't matter which side you want to find. This one or this one. Doesn't really matter. If I want to find that one, here's my angle. 16 is opposite of that angle. The side I'm trying to find is adjacent to that angle. So which trig function is that? Tangent. Tangent of 50 equals opposite over adjacent. Remember, when you write these trig functions, it's either going to be this one missing, or the angle missing. And you got to solve for it. So, if it's the bottom that's missing, to go through all the algebra, you'd have to get the x out from the bottom by taking both sides times x. That would cancel off. And then this would be an x here. Then you would have to divide by tangent 50 to get the x by itself. But everyone remember just what ends up happening? They just end up swapping spots. X equals 16 divided by tangent of 50. Now, hopefully I'll remember, I probably will, but your calculators, remember, got to be set to degrees or else the answers will be off. So 16 divided by 50 tangent is 13.4. So you can either label it that side CN is 13.4, or you could just put it up on the drawing. Then the third side, once you know two sides, you can find the third side by doing the Pythagorean theorem. Since it's the two legs, we know, remember the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So when it's the two legs, you gotta add them. 13.4 squared plus 16 squared, and then square root it. And it's 20.87 or 20.9. So again, you can label the picture, or you can write down here that CT is 20.9. But make sure if you write it down here, you say what side you're talking about. Okay, if you don't put it in the spot. So for number 5, we know two sides. So again, you can find the third side just like we did here. If you're looking for the hypotenuse, it's leg squared plus leg squared square rooted. And that's 8.9. Another thing just to check is when you're done with the sides, make sure your hypotenuse is the longest side. If it isn't, that just means you either added when you should have subtracted or subtracted when you should have added. So here 8.9 is longer than these two, so should be okay. Now, you can find either angle, it doesn't matter which one. If I find angle A, I could use this, but since it's rounded, you're better off just using the two given to you. 8 is opposite of A, 4 is adjacent to A. So that is sine, cosine, tangent. Tangent, opposite over adjacent. So the tangent of A equals opposite 8 over adjacent 4. So if it's the angle that's missing, that's when you got to use the inverse key. You get that tangent out of there because you want to get A by itself. So when you move it, it just turns to its opposite, which is tangent -1. It's pronounced tangent inverse of 8/4. So that's where you use the inverse key, the key above tangent. So 8 divided by 4 is 2. Tangent inverse of that is 63.4. So angle A is 63.4 degrees. And then angle B, A and B, or the two angles, will always add up to 90. So just subtract that off of 90. 26.6. Number 6, you know this angle, so that one's easy to find. They got to add up to 90. So just subtract that off of 90 and you get 43 for angle J. Then find whichever side you want. I'll find this one. 47 and X are adjacent. 47 and 16, 16 is the hypotenuse. So adjacent and hypotenuse is cosine. Cosine of 47 equals adjacent side X over the hypotenuse 16. So here we had all three types. Here it was the bottom missing, here it was the angle missing, here it's the top missing. So to solve, get X by itself here, you just multiply by 16 to get it to cancel. And that's 10.9. So again, you could just label it up here. If you don't put it on there, make sure you say that HI is 10.9. Then in order to find the third side, just use the Pythagorean theorem. If it's a leg missing, you got to square them and subtract them. 16 squared minus 10.9 squared, and you square root it. $11.7. Or you would say IJ is 11.7. So for number 7, We know two sides, so find the third side using the Pythagorean theorem. It's a leg you're looking for, so you gotta subtract them. It's 21 squared minus 17 squared and square root it. 12.3. Then, if you're looking for an angle, you gotta find both of these. It doesn't matter which one you find. If I wanted to find t, 17 is opposite of t, 21 is the hypotenuse. Opposite and hypotenuse is sine. So the sine of t equals opposite, 17, over the hypotenuse, 21. So to get the t by itself, you gotta get the sine out of there. It just turns to sine inverse. And that's 54.04, so that would just round to 54. And then remember angle R and angle T would have to add up to 90, so just subtract that off of 90, and that is 36 degrees. Okay, then the next page. A sonar operator on a ship detects a submarine at a distance of 200 meters and an angle of depression of 40 degrees. How deep is the submarine? So in this right triangle, does everyone know what piece you'd have to find? The depth would be right there, straight up and down. So here's the angle. 200 is the hypotenuse. X is opposite of the angle. So opposite and hypotenuse is sine. Sine of 40 equals opposite x over the hypotenuse 200. So to solve for x, get rid of the 200. It's divided, so you multiply by 200 to get rid of it. And that'd be 128.55, so we just round it to 128.6 meters. Now this next one is kind of like two problems in one. They have the picture, they don't have everything drawn in. Right here it says two buildings are 80 feet apart. So that piece right there is 80. This is also 80, but we don't really need it down there. A person on top of the shorter building finds the angle of elevation to the top 18 degrees and the angle of depression to the base 28 degrees. How tall is the taller building to the nearest foot? So this is the one problem, you don't round to 10th. When you take your MCA and your ACT math test, they always throw different things in at the end to make sure you read the whole thing. So we got to do that once in a while too. So to figure out how tall the taller building is, that means you got to figure out that. But it's a two-step part. You can figure out what this is, and then what this is, and then add them together to find the whole building. So to figure out x, x is opposite of 18, 80 is adjacent to 18. The hypotenuse isn't involved. So we got to do tangent. Tangent of 18 is opposite x over adjacent 80. So I'll take it times 80. And you get 25.99 or 26. Then to find y, you do the same thing. Again, y is opposite and 80 is adjacent, so you use tangent again. Tangent of 28 is opposite over adjacent. So you solve it the same way. To get the y by itself, you got to take it times 80. $42.53, we're on to 42.5. So together that does add up to 68.5 feet, but when it says round to the nearest foot, you would write 69 feet, because 68.5 would round up to 69. Okay, an escalator. New stores being built, an escalator's planned. It'll make an angle of 40 degrees with the floor. If the vertical distance between the floor is 15, how long will the escalator be? So they're looking for the hypotenuse. So from the angle, this is opposite, and x is the hypotenuse. Opposite and hypotenuse is sine. Sine of the angle, 40, equals opposite, oops, which is 15, over the hypotenuse x. So again, when that's missing, you swap spots. So x equals 15 divided by the sine of 40. 23.3. Now, the next one, it says if the angle made with the floor is changed to 35 degrees, will the length of the escalator increase or decrease? You could explain this without actually solving it, because it says to explain, and then say if it's longer. The easier way is just to show your work. In math, if they say to explain, the easiest thing is just to show what you do. So just solve it with this. It's the same problem, except this changed now. So it's the sine of 35 equals 15 over x. Same exact as here, except the angle changed. So you switch those two. And it's 26.2. So to answer the question, does the length increase or decrease? It increased. It went from 23.3 to 26.2. So again, explaining, if you show your work, that's the same as explaining. Then these are what we just corrected. Draw vector PQ in the coordinate plane, write the component form, find its magnitude, round to the nearest tenth, and also find its direction. So, here's the axes. Make sure you plot these points right. If you plot these wrong, you're going to get everything wrong. P is negative 1, 3, x, y. That means you go side to side, up and down. Left 1, up 3. Label it P. Q is 2, negative 2, so that's over 2, down 2. And then draw in the vector. So the component form of the vector is, to get from P to Q, remember, it's not slope. You don't go rise over run. You go over and then up or down. So this goes over 3 and down 5. So there's the component form. The magnitude is just the Pythagorean theorem. It would be 3 squared plus 5 squared, square rooted. This is 3, that's 5. You don't need to worry about the negatives because it's a distance. Is 5.8. And then the direction is the angle formed with the horizon. So to figure that out, P, tangent of P equals opposite over adjacent. Vectors always use tangent because you always know the opposite and adjacent. So to figure out P, you got to use the inverse key, move the tangent over, find the tangent inverse of 5/3. And it's 59 degrees. and it is going down, which is south, and it's going to the right, which is east. So you have that, and that, plus the drawing. So this one, 4, 2 is over 4, up 2. Q is -3, -2. Draw the vector. The component form, to get from P to Q, I gotta go left 1, 2, 3, 4, 5, 6, 7, and down 1, 2, 3, 4. So the magnitude is the length of it, so you just use the Pythagorean theorem, 7 squared plus 4 squared, square rooted, is 8.06, so that's 8.1. And then the direction is the angle formed with the horizon. So the tangent of P, because that's the angle we want, is opposite, which is 4, over adjacent, which is 7. So P is the tangent inverse of 4/7. 29.7 degrees. And that's going down, so that's south, and it's going left, which is west. Okay, here's the simple ones. Easier than the first two problems. U plus V means you add these two vectors together. You just add the x's. 3 plus -7 is -4. -4 plus -8 is -12.
Hey, slow down.
V plus W is these two. So you add -7 plus 6 is -1. -8 plus 2 is -6. V plus Z is this, there's V and there's Z. So -7 and -3 is -10. -8 and -2 is also -10. Make sure you put the vertex or vector symbols on there. Then one more trig problem. At 2 o'clock, the shadow of a lighthouse is 30 feet. So they don't have the number there, but this is where the shadow would be. The angle of elevation is 70. So that's 70 degrees right there. Angle of elevation is looking out and up. They're wondering what's the height of the lighthouse. So X is opposite of the 70. 30 is adjacent, which means we use tangent. Tangent of 70 equals opposite over adjacent. The lighthouse over the shadow. So we just take it times 30. And it's 82.4 feet. Now this next problem, this was at 2 o'clock, this is at 4 o'clock. The angle of the elevation of sun is 50. So now this changed to 50 degrees. Find the length of the shadow. Obviously the shadow is going to change, right? But what doesn't change in this picture? The height. The one you just figured out. That's going to stay 82.4. So you do the same problem, it's just now we know different things. We don't know the shadow, but we figured out the height. So the tangent of, now the angle's 50 instead of 70, equals opposite over the shadow adjacent. So this one you need to switch. X is 82.4 divided by the tangent of 50. (69.1 degrees or feet). Then the last one is kind of a common sense one when it says to explain. At 6 p.m., will the length of the shadow be longer or shorter than it was at 4? Okay, at 2 it was 82 feet, at 4 it's 69 feet. What happens to shadows as the sun goes down? You guys must live in a different universe. As the sun goes down, what happens to shadows? They get longer. You can see here at 2 it's 82.4. At 4 the shadow is this one's backwards, isn't it?
Yeah.
The sun's going the other way. Well, hold on, I gotta go back and look at that. But shadows, what happens to shadows? They get longer. This one, the numbers got switched around because I switched them. And the reason why is because shadows get longer as the sun goes down.